Hello students, welcome back to the fourth video of this playlist. In this video, we will be solving the fourth question from the recent past paper of Pure Mathematics 2, which is the May 2024 P2 paper. So let's get started with question number 4. So in question number 4, it is given f of x equals to x minus 2 times twice of x squared plus 5x plus k plus 21, where k is a constant. So part A here, it is asking to state the remainder when f of x is divided by x minus 2. Okay, so if f of x is divided by x minus 2, then what would be the remainder? So we will just use the remainder theorem in this case. So for remainder theorem, we will put x equals to 2 in f of x, okay, and then we will try to get the value for the f of x, f of 2. Okay, so if you put x equals to 2 there, so that would give you 2 minus, okay, 2 minus 2 is basically 0. So 2 minus 2 becomes 0. So this whole expression, this expression is basically 0, and you will have only 21. So the remainder is basically 21. So the remainder is 21. Fine. Okay, next is part B. So here the question says, given that twice of x minus 1 is a factor of f of x. So part B is asking to show that k equals to 11. Okay, since twice of x minus 1 is a factor of f of x, so we can easily use the factor theorem. That is basically we can write f of half, this is equals to 0 according to the factor theorem. Okay, so let's put x equals to half into the equation. So you will get half minus 2 half minus 2 times twice of x squared. So twice of x squared is basically 1 over 4. X is half, so 1 over 4, and then plus 5x, so plus 5 over 2, and then plus k plus 21. This is equals 0. Okay, so half minus 2, it is basically negative 3 over 2 times twice of 1 over 4, this is half. So half plus 2.5, this is basically 3. So negative 3 over 2 times 3 plus k plus 21 equals to 0. Okay, so we can multiply both sides by 2. You will get negative 3 times 3 plus k plus 21 equals to 0. Now multiply the bracket. You will get negative 9 negative 3k plus 21 equals to 0. So take 3k on one side. So 21 minus 9, it's basically 12. Okay. Okay, if we multiply by 2, it will become 42 instead. Okay, I have missed it out, so it will be 42 basically. So 42 minus 9, that would give you 32. Sorry, 33. Okay, so 3k, if you take 3k to the right side, it will become positive, right? And 42 minus 9, it is basically 33. So the value for k, it is equals to 11. So using the factor theorem, we have figured out the value of k. Is everything fine there? Negative 3. Perfect. No problem. Okay, so this is the answer for part B from question number 4. Fine. Okay, next is part C. Okay, at first part C1. Here the question says, hence fully factorize f of x. We need to factorize the function f of x. So in order to factorize f of x, we already know one of the factor. One of the factor is twice of x minus 1, and yeah, so we will use this factor of f of x, that is twice of x minus 1, to divide f of x using algebraic long division, and then we can easily factorize it. Okay, so for part C, let me write at first the equation for f of x. So f of x equals to x minus 2 times twice of x squared, twice of x squared, plus 5x plus 5x plus 11 plus 21. So in order to use algebraic long division, we need to expand it at first. Okay, so how can we expand it? You will get twice of x cubed plus 5x squared, multiply the brackets, plus 11x negative 4x squared negative 10x negative 22 plus 21. So we will get f, okay, f of x is 2x cubed, it is alone. So so f of x would be twice of x cubed, and then the terms with x squared, 5x squared negative 4x squared, it is just x squared plus x squared, and then terms with x are 11x minus 10x, that is just plus x. So this is just plus x, and then the constants, negative 22 plus 21, so this is basically negative 1. Okay, so this is basically negative 1. Okay, so 2x minus 1 is a factor of f of x. So we will use algebraic long division. Okay, if you use algebraic long division, we will use 2x minus 1 to divide this cubic equation. Okay, twice of x minus 1. Okay, here is the coefficient, this is the divisor, and this is the dividend. Okay, so we need at first twice of x squared, just using what, the algebraic long division. So 2x cubed negative 2x squared. So in the quotient, the term will be such that if it is multiplied by this equation, this expression 2x minus 1, the first term of the dividend should get eliminated. So that's why we picked up 2x squared. So because 2x squared times 2x, okay, it's not correct, it should be just 2x, it should be just x squared. So x squared times 2x, this will give you 2x cubed. So x squared times negative of 1, it is negative of x squared. So x squared plus x squared, it will become 2x squared plus x. Now what we need to eliminate 2x squared, we have to put plus x there, just plus x. So plus x times 2x, that would give you 2x squared. Then x times negative 1, this is negative of x. So we will have here twice of x minus 1. Okay, so at last we will have plus 1 there. So 1 times 2x minus 1, it is 2x minus 1, so remainder 0. So that means the quotient we got as we divide the f of x by 2x minus 1, 2x cubed plus x squared plus x minus 1 over 2x minus 1. 2x minus 1, it is equals x squared plus x plus 1, right? So f of x is basically the cubic expression. F of x, it is equals to 2x minus 1 times x squared plus x plus 1. So x squared plus x plus 1, can we factorize it further? X plus 2, no, it's not possible to factorize it further. Yeah, it's not possible to factorize it further. So this is the fully factorized form of f of x. Fine. So that's what part C1 has asked for. Fine. Okay, next is part 2 of C. Okay, here the question is asking to find the number of real solutions of the equation f of x equals to 0, giving a reason for your answer. Okay, so if you consider f of x equals to 0 for part 2, the earlier one was part 1, so this is C1, okay, and this is C2. So for part 2, if you consider f of x equals to 0, that means 2x minus 1. Okay, the question has asked just for the answer. Find the number of real solutions of the number of real solutions. Okay, so we need to state a reason for the answer. Okay, so if you consider f of x equals to 0, it will be 2x minus 1 times x squared plus x plus 1 equals to 0. So here for x squared plus x plus 1 equals to 0, there are no real root since b squared minus 4ac is less than 0 for this quadratic factor. Hence, how many real roots? One real solution. One real solution to the equation f of x f of x equals to 0. That's it. That's the answer for part 2 of C from question number 4. Fine.